Yes, okay. Good morning again. My name is still Marit van Dijk, and I'm here today to talk to you about reading code. And the reason I want to talk about reading code is that as developers, we spend more time reading code than we do writing code. We read code when we're adding new features, fixing bugs, trying to understand a new system or new code base, when we're doing code reviews, when we're learning about new technologies and reading about them with code examples, etc. In fact, developers on average spend as much as 58% of their time comprehending existing source code. And that's a quote from the book The Programmer's Brain by Feline Hermans. Feline Hermans is a literal professor of computer science education, so her research domain is exclusively teaching programming and learning programming. And she wrote this book that I will use throughout my presentation, and I highly recommend it. I don't get a commission, I just really, really love this book. So while we read code more than we write it, we don't practice reading code explicitly. We learn programming by writing lots of code, right? Yeah. So Feline, during a presentation, talked about how to teach programming. Again, that's her domain. And she cited a study from 1992 where they split a classroom that was learning programming into 3 different groups. The first group would write code and read code. The second group would write code and read code, but the code would have explanations of why particular choices were made when writing the code, etc. And the last group would only read the code with those explanations on why particular choices were made, etc. And they found that at the end, group 2 and 3 were better at reproducing the programming concepts that they were supposed to learn. So over the group that was writing a lot of code but not reading any explanations, which is not how we learn programming. And when she did this talk, someone after came up to her and said, so what if we did practice reading code explicitly? And that's how they started Code Reading Club. So they started a club specifically for reading code, doing structured exercises. And when I heard or read about it, I don't remember, I was like, that sounds amazing. I want to do that. And I got really lucky because a friend of mine contacted me and said, hey, we are starting a code reading club. Do you want to join? I'm like, do I? Yes. So I started a code reading club with several people that I know from conferences and who know each other. We're in different countries, so we meet up online. We have different job roles, different industries that we work in, different programming languages that we use. But I really love it, and I'll tell you why. So what we do in Code Reading Club is we print a sample of code. And this can be any language. Sometimes it's code that people have written themselves or have taken from their code bases. Sometimes it's code that we find online. But it will be a small sample that's 1 page or 2 pages long. And we use that sample and we do structured exercises to try and make sense of the code. And I'll give you some examples of those exercises, just so you have a picture. Has anybody done a code reading club or code reading session before? I get to tell you all about it. Yay. So the first exercise we usually start with is called first glance. That's literally what it is. You take 1 minute, you glance at the code, and you write down the first thing that you notice and why, and the second thing that you notice and why. And this is really interesting because you find if you have a group, especially if they have different roles or different backgrounds, people notice wildly different things. Some will notice, oh, I saw this because that's a familiar concept, or I saw this because that's syntax I've never seen before. But it's interesting to get those different perspectives. Another exercise is to identify components and relationships, so find all of the variables and where they are used throughout the code, or find the methods and where they are called throughout the codes. Of course, that's something that an IDE will help you with, but it can be useful to do so for a piece of code in a language that you've never seen before and find whether you're able to do it or not. We then pick most important lines. So pick the 5 lines that you find are most important in this piece of code. And this, again, is an interesting exercise, especially if you don't agree upfront what most important means. So some people will pick these are the lines that help me understand what this code is about. That might include the name of the class or a comment. Some people pick these are the lines that determine the control flow throughout the code. We have some testers in our group. They chose, these are the lines that help me define the most test cases because decisions are made. And it's really interesting to have that conversation, not just of can we agree on which the most important lines are, but why do people pick particular lines? We might identify concepts in the code that either we are familiar with or that we don't know, and usually someone in the group will be able to explain concepts that other people don't know. So we also learn from each other, which I love. And in the end, we will take a few minutes to write a summary of what we think the code does. And what's interesting to me is even though the previous exercises didn't really deep dive into what does the code do, somehow by working with the code through these exercises, we're usually able to get a rough idea of what does the code do. So yeah, I found that really interesting. And what I learned from Code Reading Club is not just exercises to read code, so the skill of reading code, but what I loved even more was learning about other people's perspectives and learning that something that was very obvious to me was not so obvious to people who are used to different languages or different domains, and vice versa. But also noticing assumptions that I made. Oh, this might not be relevant, or this is quite obvious, and then people had really good questions about it. I'm like, oh, I never thought about that before. So, you know, whether code is easily read is also a bit in the eye of the beholder, and it can help you to do these exercises with other people to get some idea of, am I writing readable code, and what should I take into account? And also have some compassion that, you know, sometimes they might not understand something that you do, but it can also be the other way around. And I think we can all use more compassion. So the whole point of Code Reading Club is also not reading the code to judge, as we are quick to do when we are developers reading code written by different developers. I can see by your giggling that you agree. Not at all. But we're reading code to understand the code. And I think that that can be good also to keep in mind when you're encountered with code that you have to work on, or that your coworkers have written, or even that you yourself have written 6 months ago, because that's also a totally different person. So first try to understand what the code does, and then maybe you can have an opinion on it. So in Feline's book, she talks about reasons that code can be confusing. And she notes three reasons. There can be the lack of knowledge, a lack of information, or a lack of processing power in the brain. And these also sort of map to the way our minds work. So lack of knowledge is lack of things in our long-term memory, things that we know. Lack of information is related to our short-term memory, so the information that we have available right now. And lack of processing power in the brain is related to our working memory, how much information can we process at a time. So lack of knowledge can be in the programming domain. It can be language that a language that we're unfamiliar with. It can be syntax that we haven't seen before or aren't quite sure about anymore. Programming structures, algorithms, design patterns that we may or may not know. All kinds of things in the technical domain, maybe a library that we haven't used before. Or it can be in the business domain. So it can be domain concepts or business logic that we're unfamiliar with, especially for maybe switching teams or switching to a different industry. And how can we deal with lack of knowledge? Feline recommends to create a list of the concepts that you're unfamiliar with, because that will give you a checklist. If you just start searching for the things you're unfamiliar with and just to use your favorite search engine, start searching for stuff, you might end up going down a gazillion rabbit holes and not have an idea of how much progress you've made on the things that you wanted to research. So create a list first of the things that you want to understand and then research them. And if it's something that you really should know, because it's syntax that is used throughout the code base or a pattern that is used throughout the code base, then maybe memorize some of that information so that you don't have to go looking for it every time. A lack of information can be unknown details in the code. So the code might call a method of a standard library, but you might be fuzzy on the details of what that method does exactly. It might be unfamiliar names, if it's a pattern that you're unfamiliar with or a domain that you're unfamiliar with. Code might be connected in unknown ways, so you might not know where is this code called from, where is it used, or there might be too many things going on at once that you can't create into a coherent picture. And a way to deal with this lack of information, because it's related to your short-term memory. Who's ever heard that we can keep 7 plus or minus 2 things in our mind at the same time? Turns out it's actually less, because that's also what I learned when I studied psychology 2 years ago, or 20 years ago. Yes, I'm old. It turns out it's actually less. It's more like 2 to 6 things that we can keep in our mind at a certain time. So if we get lost in details, those slots quickly fill up. If we can take a step back and notice patterns or things that are related, like model view controller, if you're familiar with that pattern, that takes up 1 slot. If you're not familiar with that pattern, model view controller are 3 things. So you can hold less information in your short-term memory. So see if you can find patterns and group it. Finally, there's the lack of processing power in the brain. If there's just too much going on, there can be too many processing steps. Think of data going through a pipeline where it's being processed in a gazillion ways, all chained together. You can be fuzzy on what's going on there, or there can be just simply too many variables to keep track of in that code, so you can't compute in your mind what the value is of those variables at a given time. There are several ways we can deal with that. Mainly memory aids, so we don't have to store it all in our minds, like a dependency graph or a state table. This is an example of a dependency graph. Before someone asks, I don't know where this code came from. It's a screenshot that I took from Code Reading Club. But you can see here that they annotated the code, so they found the variables and the methods, and then where they are used throughout the code, which will give you a bit of an idea of the shape of the code and which variables or methods you might need to focus on. Or a state table, I'm using an extremely simple nested loop that maybe you'll still be able to work out in your mind, but you can extrapolate from there to more complicated situations where you need to track multiple variables. A state table could help you with that. Felina is or was, I'm a bit fuzzy, is or was writing a new book called Code Reading in Practice. There was an early edition on O'Reilly, but I just looked for it this morning and it's not there anymore. So I don't know if she abandoned the project, which would be sad because it looked like something that was really interesting. And in Code Reading in Practice, she talks about 4 dimensions of code reading: structure, domain, concepts, and context. Structure, because code isn't read linearly. We don't read it like a novel from start to finish. That's not how it runs either. It will call to different places. So when we're reading code, we also shouldn't read it from start to finish. And in fact, research has shown that we scan the code for the shape of the code, how deeply nested is it. We look at the white space, and we look at anchors, like the names of variables, to help us figure out what the code is about or where to look more closely next. And that kind of ties in with the first glance exercise as well. The next is the domain of the code, which can be split into behavior, like this dog is behaving nicely. Behavior of the code, what does it do, and data, what does it deal with. Concepts, which again can be in the programming domain or the business domain. And the context of an application. So why does this application exist? How did it come to be? Is it a greenfield application for something entirely new? Is it a microservice that was once part of a monolith? Is it rebuilding an existing application, but maybe in a different language or a newer technology? Or and all of those will influence how we build that application or how the code was written. So when we then read code in our IDE, because I do work for a tool vendor, so I'll use my favorite IDE, which is IntelliJ IDEA. Sorry. So we might need to get a bigger picture of understanding a new code base. For example, when we have a new job, we join a new team, a new organization, or if we switch to a different team at our current job, or if we inherit a code base from a different team, or want to collaborate on a different code base, or even an open source project, we'll want to understand this new code base. We'll need to figure out, what does this code do? We might want to get some context. Again, how was this application created? What is its place in the landscape? Hopefully, if we're onboarding to a new team, one of the existing team members can provide us with a bit of context. Vice versa, if you're onboarding people onto your team, provide them with a bit of context. How did this application come to be? What is its place in the landscape? Who are the users of this application and the other departments that we deal with? What are the other applications that it communicates with? Where are we going with this application? Are we actively developing it and adding new features? Or is it basically in maintenance mode? It's running in production. It does everything it should. We just need to make sure it keeps running. Because that might also influence what you focus on when trying to understand that code base. So when reading code and getting to know a new code base, a good place to start is, of course, first to check out the code into your IDE. Because then you can do a bunch of stuff that you can't do if you're reading it on GitHub or GitLab or whatever you use. So let's take a look. Can you read this in the back? Or yes, no, maybe? Yes? Okay, good. Nope, that's... Now you can read it, right? Okay, so I'm using Spring Pet Clinic as an example. Anyone familiar with this project? It's a demo project. Lots of Spring developers then? Okay, so it's a demo project by the Spring team. Let's say we want to figure out what this code does. We might start by looking at the project tool window to look at the structure of the project. We might look at the packages. So we see that there aren't a lot of modules, not a lot of packages. We can look at the details. We see that some are technical in nature and some, let me scroll down, are more related to the domain. We have owners, pets, and vets or veterinarians. Does everybody know what a veterinarian is? Anybody doesn't know? Okay, a doctor for pets. Good. So here we see we have only a few domain concepts. The application is not too big. We can probably figure it out from here or get a general idea. If we want additional hints, we might create a diagram of which classes we have and how they are related. And that gives us a bit of an idea. We might want to, if we have to work on this application, want to make sure that we can actually build the application. I highly recommend always figuring out whether you can build the project before you make changes to it, because if you make your changes and it's broken, ask me how I know. So make sure that you can build the project before you make changes. In this case, Maven Clean Verify works. If not, you might need to check the README for information on how to build and run the project. Hopefully your applications will have a README that contains some information on where to find documentation, if there is any, how to run the project, how to run the tests, how to build the project, any special software or anything else that you need to do so. This is unfortunately not always the case. I've been on a team where we had several microservices that were all built in different ways. This was, you know, Spring, Jetty, Tomcat, and the READMEs were literally, this is the repo for this project. So one of the first things I did was to add information to all of the READMEs on how to build the project, because I'm old, I can't remember. So finally, we might want to actually run the application. to see what it does. There you go, puppy tags. So here we can look at the outside of the application, figure out what it does. So we see that we can find owners, we can find veterinarians. They've even built in a demo of an error message, so we can see what that looks like. And if you need to figure out what that error message does, you can go to the stack trace where that error message is thrown, or Wi-Fi willing, you can ask AI Assistant to explain it to you. If you're using AI Assistant or any kind of assistant, AI generated stuff, so it can help you explain the error message. But this is a fairly small and simple application, not too complicated. What if we have a bigger application? So I'll use Cucumber JVM, which is the Java implementation of Cucumber. Cucumber is a behavior-driven development tool, which, if you're not familiar, doesn't matter. We're just looking at this project as a larger project, a less standard project. So as you can see, this project has a lot of modules. So if we want to figure out what this project does, it might take us a bit more time, and we might need some additional tools to do so. So I happen to know that most modules include a README to describe what that module is, so that will give us some hints. We might see some modules with names that we recognize, like JUnit, or names that we don't, like Pico container. So we might create a list of stuff that we want to research further if the README doesn't explain them. But we might also be searching for where to even start in this application. There's a module called core, so that would be a good place to start. But we might want to have a look at how these modules are related. So for that, we can look at something called a dependency matrix. And the dependency matrix will show us the modules and how they are related. Let me see if I can make this bigger. Maybe that doesn't work quite in the presentation mode. Interesting. This is stuck in presentation mode. I need to file a bug later. So as you can see here, we have the same modules that we had in the project structure, but they are sorted differently. They're no longer alphabetical. The reason for this is the modules that are used by a lot of other modules are in the bottom, and the modules that use other modules are sorted towards the top. And we can see the blue squares represent the dependencies between modules. So obviously, since it's a matrix, the rows are the same as the columns, but the names of the columns have been omitted for space. So we can also click a square to see. Yeah, so here in the legend, you see what the colors represent. So blue represents there are dependencies between these modules. And then the direction of the module is that, or direction of the dependencies is that green uses yellow. So if we click one of the squares, we see that Cucumber Core is used by Cucumber Java. We can click for more details as well if we want to look from modules into packages into classes. But this is just to give you an idea that this is a tool that you can use in IntelliJ IDEA to give you a bit of an understanding of the dependencies between modules, etc., between the components of your application. You could use this to draw your own diagrams. Or if you want to, you can have the tool help you again. So we can also generate a diagram for the project modules, but as you'll see, this is only one side of the dependencies. So this is only Cucumber core uses these dependencies, but it's not the other side of, and it is used by all of these. But together they will help you get a picture. And I would either way recommend that you draw your own diagrams for two reasons. One is that an automatically generated diagram can be way too big, depending on the number of classes or elements that there are. And even though you can search it and you can focus on different areas, it's much easier to draw your own that includes everything that's relevant to you at that point and not relevant, and exclude everything that's not relevant. But also research has shown that if you draw your own diagrams, you're more likely to retain that information versus looking at an automatically generated diagram. But having the automatically generated diagrams can help give you some information that you can then use for your own diagrams. So different things that we can look at if we're onboarding to a new code base are the project structure, the README, diagrams, dependencies, and we can build and run the application to know that we are good to go. I'll share the slides at the end. Strategies that we can use outside our IDE is, again, identify components, identify relationships and dependencies between those, draw our own diagrams, identify any concepts we might want to research or might want to know more about. We can hopefully ask some of our teammates for a quick overview or read some documentation, do our own research, and gain a bit of context for that application. And that especially is where your teammates hopefully can help. A next way to familiarize ourselves with an unfamiliar code base is to look at a particular slice of the application. So that might be related to a particular use case or a particular thing that you're trying to accomplish right now, or it can just be a generic way to have an entry point into the application and look at just a part of the application to build up your mental model of the whole. So to do so, we need to find a starting point. Those starting points can be, depending on what we are trying to do, can be a generic starting point, like a main method or an endpoint, or it can be specific, like an error message or an exception that is thrown if we have errors in our logs that we want to figure out where they're coming from, or a specific logic or functionality that we're looking for if we are trying to answer questions on how does this work, or trying to fix bugs or add functionality. Yeah, so how can our IDE help? Let me close this. So if we want to look for the main method, public static void main. Of course, I never can type if people are watching. Anyone else? Oh, wrong application, wrong demo. I wanted to show you in Spring Pet Clinic because that's much smaller and easier to find. So we already see multiple mains, but let's go for the main. No, that's not it. Sorry. So in a Spring application, if you find the main method, that's where the Spring magic starts. Now that we found it, not very useful, sorry. So maybe we might want to look for a controller instead. Again, I can't type if people are watching. So we might want to look for a controller instead and pick an endpoint as an entry point. So we can go from the endpoint to down into the application all the way to the database and see what happens. This is a fairly small application. There's no service layer, no business logic being applied in between. So we can go down to the repository and back up again. If we want to have an overview of endpoints, we can use the endpoint tool window. So we can use this and then go to specific endpoints. And that will give us an idea of entry points into our application that we can follow all the way down and back up again and see what happens with the data that we enter or retrieve. So those are fairly generic if you're trying to understand what an application does, or a specific endpoint might be related to the task that you're trying to do. You might also look for a specific error message. So you search for that error message, find the place in the application where that is used, and then from there you can trace how do we get there, what might be going wrong. You can figure out where in the application you are to get a bit of an idea of where you are in the structure. So there are different ways that we can search and navigate our code base, which is very useful, and that's a reason that you want to read the code in your IDE. So outside of the IDE, we can think about a particular use case, read documentation about that, draw our own diagrams, which might also be flowcharts of how the behavior goes through the application. And we can combine that with looking in our IDE. Finally, we'll find a piece of code that we need to understand. And here, especially if the code looks unfamiliar or unclear to you, structured exercises can help because they give you something to hold on to, something to do when trying to understand the code. So I'd recommend doing some of those, but of course also our IDE can help us. So in our IDE, obviously, we have hints that any editor provides us, like syntax highlighting, inlay hints of where code might be used, all kinds of hints that you get immediately from your IDE. If you write the code in an IDE, it will probably already be properly formatted, but if not, we can easily reformat it in our IDE, which we can't do if we're reading a book or printed out code or of any kind. We can restructure code and move code up and down, if I can remember the right shortcuts. So we can move the public methods above the private methods and sort of rearrange the code to make it easier for us to understand, to have a more familiar structure. We can collapse code, collapse all code, to get a quick overview of the methods. Because I'm zoomed in right now, you don't see all of them and I'm scrolling, but normally if you have if you're not in presentation mode, you'll see, depending on the length of the class, you'll see more, of course. There are other ways to get an overview, like a file structure, so you can see all of the methods and fields in a class. Or you can use the structure tab to see the methods and fields in a class. So there are different ways to get an overview of what's going on in this piece of code and to see the structure. We can, of course, navigate to, again, to where methods are called and back again. And back again. But we can also pull up additional information. So instead of navigating to and from, we can see the documentation of particular classes that are called either by hovering or by explicitly pulling up quick documentation. We can ask for type information if it's not clear what something, what a particular method returns. Of course, if you're using types in Java, then it'll be clear from the signature, but if you're using vals and vars, that might be useful information to have right there, so you're not overwhelmed by getting too much details by moving back and forth. Obviously, if we have tests, we can navigate to the tests. And I don't know, did anybody join Kevlin's workshop yesterday? So way more useful information on testing there, but hopefully the tests will have meaningful names that describe the intended behavior, so they serve as a type of documentation. I'm using the should, which Kevlin said I shouldn't, so I need to revisit my tests as well. But at least it says, you know, if the order is paid, the items should not be cancelled, it should be registered. So this tells me a little bit of the intended behavior. If we set a breakpoint on registering the order and then run this test through the debugger, we can see how the code is actually executed. Depending on how complicated the code is, we might be able to figure this out in our head, but I never trust my own assumptions, so I like to actually see it and verify that my understanding is correct. So we can run the code through the debugger. It will stop at the breakpoint, and from there we can either step over a line, meaning we go to the next line and don't go into all of the methods that are called, or we can step into a line and then it goes to the methods that are called depending on the level that we're interested in. And then continue the execution. And of course, we can see on each time that it's stopped, we can see the values of our objects in our fields, etc. So if we're creating a state table, this could help us as well to figure out how the values of the variables change or whatever. We can look at the state at a particular point in the execution. If we're doing this in a Spring application, we will quickly end up in the Spring code. And we can resume the program when we're done. What else? So I know that we said we would read the code to try and understand the code and not have an opinion on the code. But sometimes code might be using a style that you're less familiar with, or you might want to rename things as you're trying to, or as you gain more understanding, just to make it clearer to you. So you can refactor code for understanding. For example, let me find the right. Right. If we're registering this order, we might figure out that item is actually an order item, so we might want to rename that to order item to help us be more clear and explicit about what's going on. We might want to extract a method to give it a meaningful name. My shortcuts aren't working. Sorry. So we might want to extract methods, give them a meaningful name, break up a longer method into shorter methods to make it easier to read, and sort of just play with the code as we gain more understanding and refactor it into a shape that we are more familiar with. For example, also in terms of style, if you're more familiar with a loop, you can change the stream to the loop. Or back again, depending on what you're used to, and just basically play with the code to verify your assumptions, make it easier for you to read and understand, and then in the end, undo all of those changes because they were only for you to help you understand the code and not necessarily changes that you want to make to the code base. We might want to look at the context of how the code came to be. Thank you. So we might want to annotate with git blame. Git blame is a lovely name for a command. Anyway, so we can see when lines were last changed and why. We can click them to go to the specific commit. We can look into the specific commit and look at the diff to see what was changed. Hopefully, the commit message will give you some information on why it was changed. In my previous job, we had the habit of including the ticket number for the story that we were working on in the commit message so that we could go to Jira or UTrack to find the information on that story to hopefully provide some context. Something that a feature that I really love is that you can explain a commit with AI assistant, which if the commit message is clear, you might not need it, but if you want some additional information or you're not quite clear on why the changes were made, you can ask an AI assistant for help. That's one of the most useful features that I've found so far. I'm used to using tabs, so I'm a little bit confused from being in presentation mode. Going back to my class, we can switch off the annotations again. We can also use an AI assistant to explain code to us. And of course, we can ask questions in the chat window to help explain this project or explain this code or ask questions about specific pieces of code. But we should be aware that it's powered by LLMs. So it's very smart predictive text. Depending on how common your code is, it will get it fairly correct or spectacularly wrong. So I've been playing with it. I've used it on the Spring Pet Clinic, which it's able to explain very well. If you ask, explain this project to me, it will explain it's a Spring project, what kind of dependencies it uses. Of course, most likely Spring Pet Clinic is part of its training data, so it should know. But also my own personal demo Spring project, which is, you know, like 99% of Spring projects out there, it will be able to explain that as well. But if you use it for a code base that is less common, for example, the Cucumber JVM, which is a library, you will have to guide it a lot more before you the answers start making sense. Because when I first asked it, what does this application do? It would tell me, oh, it uses Spring, so it's a web service. No, it does use Spring. So, you know, good guess. And then I had to tell it, okay, this is the library for this, for Cucumber. Now can you tell me what it does? And then it will start to make sense. So, you know, if you do use an AI assistant, be aware of what it can and cannot do for you. Be aware a little bit of how it works under the hood. And just play with it and see how you engineer your prompts to get the results that you need. And also, even when you use your AI assistant to write the code for you, you still need the skill of reading code, because you still need to be able to read the code that it gives you and evaluate whether that is the code that you want to use. So if you're looking at a piece of code in the IDE, you can look at the structure of the code, use the white space to understand the shape of the code, get hints from your IDE, either the ones that are already there or ask for additional hints. You can look at the tests to figure out the behavior, run them through the debugger if you want to see how the code actually executes. You can refactor the code to aid your understanding, but throw that away because it was used as a tool for understanding. And you can look at the context of the code in terms of Git history and its place in the larger code base. Strategies outside the IDE is, again, drawing a dependency graph, because you can find and highlight occurrences of a particular variable, for example, in a file, but you can't do that for multiple at once. So it helps to do that on a piece of paper. Create a state table as you run stuff to the debugger to see how variables change. Get some more context for the Git history, which might be outside of the code base. It might be in Jira, UTrack, or whatever you use for issue trackers. It might be in documentation. It might be in architectural decision records. Thank you. So what's next? Hopefully I've managed to convince you that Code Reading Club is useful. So if you would like to give that a try, you can go to their website, Code Reading Club. They have a Discord that you can join if you have any questions. And they have a bunch of resources that you can find on GitHub, including a starter kit. So if you want to start your own Code Reading Club, they have 3 or 4 sessions already planned out for you with a code example, which is harder to find than you might think, to have a code sample that is 1 or 2 pages, and exercises and notes for a facilitator, so you can get started with that. Again, I highly recommend The Programmer's Brain by Feline, and I'm not sure whether it will come out. Code Reading in Practice might be an interesting book as well. And The Programmer's Brain also has a bunch of additional exercises that you can try to apply to your code. So in summary, let your tools help you. So use the features of your IDE in finding, searching, navigating, getting all of the hints for the code that you can. but also use your brain and be aware of how your brain works, why code is confusing, how you can help your brain make sense of it. And if you would like the slides or any additional links, you can find them on my website. And if anybody has any questions, please let me know. If you're not comfortable asking in a large crowd, I'll be here all day and tomorrow. So if you have any other questions, come find me. Thank you. Any questions? Urgent, burning questions right now? Okay. Again, as I said, if you have any questions, come find me. Let me know. Thanks.